There is also this concept about causal discovery. If I'm not wrong, you also talked about it in some of your LinkedIn posts. Uh,
Yeah.
to educate people, the difference between causal discovery versus causal inference. How would you go about it?
Yeah. So let's take Pearl's framework because that is where we do causal discovery. So, right, when you take Pearl's framework, if you do causal inference, you have a question you're interested in about the effect of a variable on one other, and you have a system of interactions like this variable causes changes in this variable, and maybe you have a handful, who knows, 10 variables, and you draw a diagram of variable one causal, it has a causal impact on variable two and variable four, right? And you put arrows and you draw your system like that, and then you use Perlian techniques to study that system with data. That is causal inference. You are trying to understand a system of variables, estimate quantities, and decide if the quantities that you estimated help you draw a certain causal conclusion. In causal discovery, you go the other way. You say, okay, I have data, um, and I want to understand what would be the arrows I have to draw between the variables in my data. And it turns out that under certain conditions, you can deploy algorithms that search the data and they can come up with plausible uh, causal graphical models to describe the data. The problem is that in Pearl's theory, there is the concept of observational equivalence, which basically means that two different diagrams, or two, three, or four different diagrams, could all lead to the same observational patterns in the data. So the causal discovery algorithm cannot differentiate between these diagrams because the observations we have do not contain information about the differences in the diagrams. So then you can use expert knowledge, or sometimes maybe one diagram does not make sense because there is a notion of temporality, or you just have an understanding of the system that you can force the model to exclude certain options. But the hope is that in very high data environments, like for example, um, I saw a demo with a startup in Germany that was developing a causal discovery tool. And what they do is they create this big data model. For example, they did a case study with a manufacturing company. The manufacturing company has sensors all over the place. It has this huge set of data. And then you just throw the algorithm at it. And the algorithm says, okay, this is my hypothesized causal interactions in the system. And then you can use that to maybe increase the performance of your processes. So, for example, they had a problem with a certain part that was having high rejection rates in quality control. So the manufacturing process was a little bit off. And they didn't know why. You want to know what is the cause of this, but there is so much data and it's so complicated. But the algorithm can kind of use the power of computing to bring down the problem to where, okay, this is my hypothesized interactions, and then a human can look and say, but this causal chain might be what is causing the problem. And it turns out in the case that they showed me that it was right, and they were able to correct the process. So I think causal discovery is a very promising tool for industry. Um, to be honest, I am not super well versed in the techniques. I know the basic ideas and the basic algorithms. And I wonder if it will be useful for science and in what capacity. But I can see why in industry it can be like a super useful tool to try to understand some causal processes in different systems.
Great.